Hello everyone, today we will be discussing normal distribution. A normal distribution is a distribution for a continuous random variable x. What is a continuous variable? These are variables that you can assume any numerical value over an interval or intervals. What are the properties of a normal distribution? First, the mean, median, and the mode are equal. Second, the graph is a bell-shaped and symmetric around the mean. Third, the total area under the curve is equal to 1, and the curve approaches but never touches the x-axis, that is asymptotic to x. Could these graphs represent a variable with a normal distribution? Let's find out. How about this graph? It is not a normal distribution. Why? Because the graph crosses the x-axis. How about this graph? Again, that is not a normal distribution. Why? Because the graph is skewed to the left. How about these graphs? This one. Again, it is not a normal distribution because the graph is not symmetrical. How about this? This is not again a normal distribution because the graph is skewed to the right. The mean and the standard deviation determine the shape of the normal curve for a population. That means the mean gives the line of symmetry and the standard deviation describes the width of the graph. This is a graph of a normal curve. This is a graph with a greater mean. And this is a graph of a normal curve with a greater standard deviation. There. Which normal curve has a greater mean? Is it graph A or P? It is graph A because the mean of graph A is 15 and the mean of graph B is just 12. Which normal curve has a greater standard deviation? Let's take a look with this graph. Is it graph A or B? It is graph B. How about this? Which curve has the greatest mean? Is it A, B, or C? It is graph B because it is the farthest graph from 0. Which normal curve has the greatest standard deviation? It is graph C. Let us now find the line of symmetry and identify the mean of this graph. There is the line of symmetry, and the mean is 3.5 feet. Let us now discuss normal curve and probability. The area under the curve is equal to the probability that a random variable will have a value in that interval. Here is the graph. Here is our mean. And here is 1 standard deviation above the mean, 2 standard deviation above the mean, and 3 standard deviation above the mean. On the other hand, we have 1 standard deviation below the mean, 2 standard deviation below the mean, and 3 standard deviation below the mean. As you can see, this is symmetrical. How about the area? The area between one standard deviation above the mean is 34%, and the area of one standard deviation below the mean is still 34%. The area between one standard deviation and two standard deviations above the mean is 13.5, and the area between two standard deviation and three standard deviations above the mean is 2.35. That is same with here, which is two standard deviation and three standard deviations below the mean. Let us apply those in estimating the probability that a randomly chosen adult has an IQ between 70 and 115. Here is 70 and 115 IQ. So the area is 0.135 plus 0.34 plus 0.34, and that is equal to 0.815 or 81.5%. Let us have another problem. Students use their computer having a mean of 6.2 hours with a standard deviation of 0.9 hours. Let us try to label the graph. Here is our mean, which is 6.2. We have 7.1 because that is 6.2 plus 1 standard deviation is 0.9. That becomes 7.1. Plus 0.9, that becomes 8. And plus 0.9, that is 8.9. On the other hand, from 6.2 less 0.9 hours, that is 1 standard deviation, below the mean is 5.3. And so with 2 standard deviation from the mean, 4.4, and 3 standard deviation below the mean is 3.5. Let us estimate the probability that a student uses their computer less than 5.3 hours. Here is 5.3. That should be less than 5.3. So that area is equal to 2.35 plus 13.5 equals 15.85%. Let us find the probability that that student used the computer between 5.3 and 7.1. Here is 5.3 and 7.1. The area between them is there. So that is 34 plus 34 is 68%. How about this one? Let us estimate the probability that a student uses their computer for more than 6.2 hours. Here is 6.2. More than 6.2 is this area. So the area then is equal to 34% plus 13.5% plus 2.35% is equal to 49.85%. Let us interpret the graph of a normal probability distribution. Use the empirical rule to complete a normal distribution graph if the mean is 75 and the standard deviation is 5. So, there is the mean, and here is 80 because the standard deviation is 5. 75 plus 5 is 80, plus 5 is 85, and plus 5 is 90. From the mean, 1 standard deviation below it is 75 minus 5 is 70. Minus 5 is 65, minus 5 is 60. How about this problem? of 2,000 students, estimate the number of students who scored less than 70. Less than 70. Okay, there is the area. That is 13.5% plus 2.35% is equal to 15.85%. But we are going to find out the number of students. That 15.85% will be multiplied by 2,000 students. Then, approximately, we're going to get 317 students. What if we are going to estimate the number of students who scored between 70 and 80? Here is 70 and 80. So the area between them is there. That is 34 plus 34 equals 68. And that is to be multiplied by 2,000 students. Therefore, we have 1,360 students. What if we're going to estimate the number of students who scored more than 80? Here is 80. Above it is this area. Therefore, that is equal to 13.5 plus 2.35 equals 15.85%. To get the number of students, that should be multiplied by 2,000. That becomes now 317 students. That ends our lesson for today. Thank you for watching.